If we're going to simplify square root of negative 100, we look at that as the square root of 100 times the square root of negative 1. Of course, this will simplify to 10i. When we add two complex numbers together, we add their real parts, 6 plus 3, that's 9, and then add their complex parts. Plus 4i plus negative 2i makes 2i. And if we're going to multiply two complex numbers together, we have to FOIL them. So we'll get 15. On the outside, it's minus 10i. The insides give us plus 6i, and the lasts give us negative 4i squared. Remember, of course, that this negative 4i squared, I squared turns into negative 1, so negative 4 times negative 1 is positive 4. Now we combine like terms. 15 plus 4 is 19, and negative 10 plus 6 is negative 4i. When it comes to this fraction 6 over 4 plus 2i, we want to simplify it, and part of the simplified fraction is that there are no square roots in the denominator. And initially it might look like there aren't any square roots in the denominator, but you've got to remember that I is a square root of negative 1, and so we do have a square root down there. So if we're going to simplify it, we need to rationalize the denominator, get the square root out of there. And how we're going to do that is by using complex conjugates, because when we multiply two conjugates together, they go from being complex numbers to being real numbers. So how I'm going to do that is I'm going to take this fraction and multiply by another fraction. In the second fraction, I want the denominator to be the conjugate of 4 plus 2i. I want it to be 4 minus 2i. That way I won't have any roots down in the denominator anymore. But if I do not want to change the value of the fraction, I have to multiply the numerator by the same thing. When we do that, in the numerator, all we have to do is distribute. Take that 6 to both pieces. So 6 times 4 is 24. And 6 times 2 is 12. In the denominator, we'll have the difference of two squares. 4 squared is 16, and 2 squared is 4i squared. To simplify the denominator, we have to remember that this minus 4i squared is going to turn into plus 4, and 16 plus 4, that's 20. Break each piece into its own fraction, 24 over 20 minus 12i over 20, and simplify those. And it looks like 24 twentieths is 6 fifths minus 3 fifths I. We break this into two pieces because it's a complex number. And complex numbers have a real part and an imaginary part. Let's do it again with something slightly more difficult. 3 plus 5i over negative 2 plus 3i. We're going to multiply by the conjugate of the denominator, so negative 2 minus 3i. And that happens in the denominator and also in the numerator. Now we're going to have to FOIL the numerator instead of just distributing. When we do that, we'll have negative 6. The outsides will give us negative 9i. The insides are negative 10i. And the last, negative 15i squared. In the denominator, we'll have the difference of two squares, 4 minus 9i squared. Now it's just a matter of simplifying. When we do that, we first of all recognize that this minus 15i squared is going to turn into positive 15. And positive 15 minus 6 is 9. Minus 19i all over. Again, minus 9i squared turns into plus 9. And plus 9 plus 4 is 13. Split it into the two fractions. 9 13ths minus 19 13ths I. And now we have a complex number. The definition of I is that I squared is equal to negative 1. That makes I equal to the square root of negative 1, which of course we just call I. When we get to I to the third, we can rewrite that as I squared times I. I squared is negative 1, and I is I, so I cubed is negative I. I to the fourth is I squared squared. which is negative 1 squared, or being 1. And now we see that what will happen when we get to I to the 5th, it'll be I to the 4th times I. And we will run through this cycle of I, negative 1, negative I, and 1 over and over and over again. Now we can use those first two to help us with any bigger power. So if we have something like I to the 19th, we think about it as being I squared first. I squared to the 9th, that's the same as I to the 18th, times another I would make I to the 19th. Well, I squared is negative 1. And negative 1 to an odd power is negative 1. Negative 1 times I is negative I. If we had I to the 270th, that's the same as I squared to the 135th, because 2 times 135 is 270. So there's no extra i's. And negative 1 to an odd power is going to be negative 1. And that's a good way to go about simplifying the cycles of I.